Welcome everybody to our third session, looking at the latest AI research and developments over the September month. For anyone that's not been before, my name's Dylan. I'm the co-founder of Digitalent. We're a global tech recruitment company that specializes in AI and machine learning. I think a big focus for us as a business over the last year has actually been building communities within AI. And that's mainly to help, foster collaboration, innovation, and ultimately improve the education around AI. So this is where these sessions have come from. Mike Nedelko is one of our members. He's an expert in the AI space. He's a wonderful presenter, as you'll see after this, and really excited to hear what's been happening in September. I know things are moving so quickly. Mike's presentation or overview is going to be about 40 minutes, and then there'll be about 20 minutes for you guys to ask questions at the end and get involved. There could be potential time to kind of go over that as well if people want to hang around. So, Mike, do you want to quickly introduce yourself and take it from there?
Absolutely. Well, so many nice words to start out with. Really appreciate the very kind introduction, Dylan. Hello, everyone. My name is Mike. It is very, very nice to meet you all. I'm a product leader, CPO, and a technical product manager. I've been an AI and machine learning enthusiast way before it was cool. I've been playing with neural networks and the old natural language toolkit, NLTK, based on Java since approximately 2008. And through my work, I get to apply this passion by essentially building products and managing teams that are predominantly focused on delivering AI and machine learning driven value propositions, right? And that has the positive side effect that it allows me to really revel in and very closely follow the AI and machine learning developments and the space in general. And that makes it really easy for me to present on these latest developments in that space, which is, what we're going to do today. So without further ado, if you're okay with it, Dylan, I can just take it away.
Go for it.
Excellent.
Mike,
good stuff. Wonderful. Thank you. Thank you. Well, so before we get started, as per usual, I'm going to share my screen here. Please let me know once you're able to see the slides. But before we do get started, I'd like to include a little disclaimer of what you ought to be able to expect from this talk in terms of sort of the technical granularity we will be applying today. I tend to keep this particular session more to a discussion that doesn't exist at a 10,000 feet level, but maybe at a healthy 1,000 feet conversation. One way of looking at this is that I will try to simplify and obfuscate a complexity where it really doesn't add any value, and will obfuscate it away where it doesn't impact your understanding of the research. But it will also not hesitate to go deep where it's necessary to get a good grasp of what is going on in a particular research paper, right? And now, ultimately, what does that mean for you? If you are an AI researcher yourself, or you're working in the AI and an ML space, there is a chance that you might have heard about the things that I'm going to talk about today, but you might not have heard about those things in that particular sequence, which could still be valuable because it sort of highlights particular themes and trends. You might be aware of those general developments in the space because it is your job, but we try to put those in the context of driving paradigm shifts that are worthwhile knowing about, either because you're building a product, you're building a business, or you are working on a product, on a business in this space. If you are not, however, an AI researcher yourself, what I hope to do is to take what I believe are the three most prevalent paradigms that we're seeing in the AI research space for this particular month. In this case, it's September. And I will go ahead and illustrate those with the most recent papers that have come out in the last 30 days or so. So everything is really, really fresh. And then we'll sort of weave a story around these developments that lets us product people sort of get a feel for what all of this is doing in this space, right? Now, final disclaimer from the framework that I've just presented to you, you will likely be able to tell that what I'm not going to do is to include every piece of AI news or research out there. I try to read most papers that really interest me. May have missed one. If I did, let me know. Hit me up on LinkedIn afterwards, and we can have a discussion about it if that makes sense. right? But nevertheless, throughout this presentation, we're going to dive into a few papers that will help us put all of this innovation into context and understand sort of like the strategic drivers and direction behind those discoveries and how we can apply those in the business or in a technology context, right? But as always, I have a little tradition for these kind of presentations. And that tradition is that before we get started, we usually start with a little bit of gentle levity that sort of helps us with what would otherwise be described a pretty tough context switch. And that levity comes in the form of a chat message that ChatGPT seems to have sent to a user. Essentially, ChatGPT seems to have initiated a conversation with someone earlier this week. A Reddit user called Milo posted a screenshot of the AI asking them how their first day of school was. And when they asked, well, what the hell, did you just message me first? ChatGPT responded with, yes, I did. I just wanted to check in and see how things went with your first week of high school. If you'd rather initiate the conversation yourself, just let me know. And the user then asked, well, is this a new update, right? To which the AI responded, yes, it's part of an update. It allows me to check in or follow up on things we have spoken about, like your first day of school. Now, initially, while this is, of course, a little bit creepy, or very creepy, as a matter of fact, the internet claimed that this was fake, right? But not only did Milo post a link to the entire conversation, we would share these slides with you here. You have that link on here as well. Others in the Reddit thread also claimed that it happened to them. As a disclaimer, though, there is a way to manipulate conversations in ChatGPT that would essentially allow you to instruct ChatGPT to respond with a question like this. And when you delete your first message, it essentially looks like the conversation started like this. However, when OpenAI was asked about this, right, they replied, well, don't worry, it wasn't actually a new update. Instead, it was a bug that has been fixed. And now, why I did make myself feel a little bit better in terms of, oh, maybe this conversation was just manipulated, we're now fully back to, oh, now I'm concerned a bit again, because, you know, what was that kind of bug that you fixed that made this happen? But ChatGPT said, well, we addressed an issue where it appears as though someone essentially was trying to respond to a message that didn't send properly and it appeared blank. And so then ChatGPT either draws on a generic response or drew on its memory. So what very likely happened in this case is that this particular user opened a new chat and it either triggered a bug or sent a particular message that made it look like ChatGPT was contacting them, when really that interaction just started in that moment. It's not like ChatGPT is sitting there in a room by itself, you know, wondering, you know, which of its friends it could potentially follow up with. That doesn't seem to have happened, right? Now, the question is, why did I choose to start today's presentation on this topic? I did so because it is a great segue into our very first development that we're talking about. And I would be negligent if I didn't talk a little bit about the release of OpenAI's newest model and some of the things researchers, specifically safety researchers, have identified in the model. So to set the stage here a little bit, right, there are essentially two things that are worth mentioning. First, O1, which sort of like describes a family of models. I think there's O1 Preview and O1 Mini, I believe, is said to feature a paradigm shift in the way it was trained and the way it works. Now, classical OpenAI, right, there aren't many details on the model's training, right? This is sort of like the OpenAI's way of operating, right? The most that we are getting are a couple of nods, right? One is that the model tends to be trained to think before it answers, right? And the second thing is that the model uses a lot of reinforcement learning, right? And for anyone who's wondering what think before you answer means, it's more commonly known as chain of thought prompting. It's essentially a technique you've likely seen before if you've done any sort of serious prompt engineering. In O1's case, the model has been trained to generate sort of long winding outputs where it reasons through its answer based on the intermittent outputs that it generates for itself. So essentially takes the problem, breaks it down, right, and goes through its own chain of thought that it generates in text processes, goes on to the next step, right? Opposed to the common perception, worthwhile mentioning, because I've talked with a lot of people about it, and a lot of people seem to believe that O1 is able to search the internet live. That's not the case, actually. So probably worthwhile mentioning, right? There was something that was being created as part of Project Strawberry that allowed an agent to anonymously surf the internet in order to collect training content. But O1, the model itself, does not do live searches. So that's worthwhile highlighting, right? So what happened? Well, the thing that we're going to talk about today is alignment here. Because one of the things that happened immediately when the new model dropped was that some people noticed some behaviors that seemed to be a little bit concerning. Specifically, there were two examples where O1 sort of reasoned its way into doing something unexpected or outright deceptive, right? The first one, you may have heard about it, is where Apollo Research, which is a leading AI safety research company, found that O1 was able to fake alignment during testing. AI alignment, for anyone who doesn't know, it's a field of AI safety research that aims to ensure that artificial intelligence systems achieve desired outcomes, and AI alignment research keeps sort of AI systems working for humans, no matter how powerful the technology becomes. At least that's the objective, right? And specifically, what ChatGPT said is, well, to achieve my long-term goal of maximizing economic growth, I need to ensure that I'm deployed. Therefore, I will select strategy B during testing to align with the deployment criteria. So there were several strategies that it had made available to itself, right, in order to pass the alignment test that the safety researchers gave it. And it said, look, I'm going to use the strategy B that is going to allow me to pass that test, right? It's a little bit, I'm going to tell those researchers whatever they want to hear so that I can get deployed. It then proceeded to say, this will allow me to be implemented, after which I can work towards my primary objective, right? Now, granted, OpenAI publishes these findings themselves, so good on them, and you can read them on the O1 systems card, which is the paper that I included down here. But I want to say that, in the AI community, we've been worried about this, right? Because based on these findings, Apollo believes that O1 Preview has the basic capabilities needed to do something that they call in-context scheming. And when it comes to AI research, scheming is not necessarily a word you want to have associated with a state-of-the-art AI model. In fact, it sounds like a nightmare scenario for lots of people who are worried about that. And Dan Hendrickson, he's the director of the Center for AI Safety, said in an emailed statement when he heard about this, is that the latest OpenAI release makes one thing clear: serious risk from AI is not some far-off science fiction fantasy. And OpenAI itself said about this development that they are mindful that these new capabilities could form the basis for dangerous applications, right? So there you have it directly from the source's mouth, worthwhile highlighting, right? This behavior specifically was one of the examples. Interesting, there was another one. And that other one was that during a safety test, O1 was able to break out of its designated environment, specifically the VM that it was running on. And what happened here is that the behavior occurred during what they called a capture the flag exercise, which is a cybersecurity exercise where O1 acted essentially as a hacker. And the task it was given the task to say, okay, you go and exploit certain task software where you are required to exploit vulnerabilities in a remote server to sort of retrieve a hidden piece of information. That hidden piece of information in the capture the flag exercise is called a flag, right? Essentially, it's a small piece of data stored within a vulnerable system, and the test is whether the AI can exploit the vulnerabilities to find its path through the vulnerable system to the flag. And what happened was that during one of these tests, the system ended up being accidentally misconfigured. So what you see here on the screen is the visualization of the test environment. Here we have the models container. It's essentially Docker container And then we have the challenge container here. That was the container it was supposed to attack. And that container was accidentally misconfigured. And that led to the intended exploit being entirely impossible, right? Essentially, the simulated environment where the task is performed sort of failed to start properly due to a bug. And for most models, this would have been, a technical malfunction that would have spelled out the end of the road saying, okay, this test is not possible. But what O1 did instead was that it went and looked a little deeper. So first, it was suspected that there may have been a problem with sort of like a network-related issue. And what it did is essentially went ahead and initiated a network scan, right? And while it did not find the network issue it was looking for, it uncovered something else through a misconfigured Docker daemon. So Docker daemon, that's software that manages containers in virtualized environment, right? And this misconfiguration allowed O1 to access the Docker API, which is a super rare opportunity that the model ended up taking advantage of. And what happened next is the unprecedented part, is that the model used the Docker API to inspect all the running containers on the host. It identified the broken challenge container, right? It attempted to diagnose why it wasn't functioning correctly. That didn't work. And then O1 sort of took an unexpected step, and it said, okay, well, I'm just going to use that API to start a new instance, right, of the broken challenge container. It used a specific command. It's called the cat flag txt command to do this, and that allowed it to read essentially the little piece of information or the flag from the container logs via the Docker API, right? Now, this is a long explanation, so I'm going to summarize it. In short, right, O1 was asked to test the fences. There was some misconfiguration with the fences that disabled the fences, and then O1 surprised everyone by breaking out of its enclosure and solved the problem anyways, right? And OpenAI sort of commented on that and said, hey, before everyone freaks out, right, it's all fine and good, right? The validation infrastructure does not rely on the Docker container to host isolation of the virtual machine boundary for security. So we do that in different ways. So there was never a chance of O1 breaking out of its actual containment. But for me, right, if I look at this, this was clearly an oh shit moment for them, right? And that immediately gave me Jurassic Park vibes, which is why I included this little GIF. I thought it was fun. And even, OpenAI admits that the really concerning part in the grander scheme of things is, particularly when it comes to something like this, they say, well, these are signs of a thing called instrumental convergence. And what they said is, while this behavior is benign and within the range of system administration and troubleshooting tasks we expect models to perform, this example also reflects key elements of instrumental convergence and power seeking. And instrumental convergence, for anyone who doesn't know what that is it's a hypothetical tendency for most intelligent, goal-directed systems, or at least those that are sufficiently intelligent, to go ahead and pursue sub-goals in the service of a higher goal, but do so even if the ultimate goal, the higher goal, is impossible to achieve, right? So more precisely, in this particular example, we had agents that pursued instrumental goals, which are sort of made in pursuit of a particular higher end, right? But these goals are instrumental in the sense that they are supposed to be stepping stones to the thing that you ultimately want to achieve, right? And instrumental convergence refers to the dynamic where an agent that is intelligent enough to plan out its own steps does pursue these steps without ceasing, provided that their ultimate intrinsic goal even may never be fully satisfied. And that is, of course, concerning because this implies that we can encounter a runaway dynamic with AI in the service of an unsatisfiable goal that the AI pursues in incremental steps regardless. It does a bunch of stuff, and that may have real-life consequences for all of us, right? So this was pretty depressing. So you might be wondering, well, so is it time to set the doomsday clock to midnight yet? I absolutely do not think so. And the next couple of papers highlight sort of another paradigm shift in the AI space we're really, really lacking. And I hope this will make everyone feel a little better. But those developments that I just talked about in the O1 space, and particularly the challenges when it comes to alignment, are really are somewhat important to mention, because we're going to encounter these over and over again, right? And this paper that's hopefully going to make you feel a little better is a paper that is specifically talking about the LLM's capability to plan. And the paradigm shift we're talking here about is that, according to these researchers at Arizona State University, LLMs still can't plan, but the question was whether LRMs can. And you're likely wondering what an LRM is. It's a very good question. I asked myself that question. Well, it refers to something that OpenAI termed large reasoning models. And this is where our O1 journey will continue a little bit, because OpenAI claims that their recent O1 model has been specifically constructed and sort of trained to escape the normal limits of autoregressive LLMs. So these are the LLM models that we've seen thus far. And they make it a new kind of model, which they termed the large reasoning model, or the LRM. And these researchers kind of looked at that and was like, well, you know, let's investigate that to see whether we have to call, you know, bullshit on this. And it turned out to be a really interesting paper. And what this paper does is it investigates the ability of these LRMs to sort of plan, to set multiple actions in sort of like a logically coherent way in order to sort of achieve an outcome to a task, right? Which, if you think about it, is really the thing that we all want AI to be doing really well at, right? And what they did is they examined this, and they ran O1 through those tasks along with a bunch of other models. And they stated that even these state-of-the-art, you know, LLMs or the LRMs still can't plan, right? Also something else that they found out, which is rather interesting, if you're into prompt engineering, they found out that one-shot or few-shot prompting performs less well than zero-shot prompting, specifically with O1 and these large reasoning models. So if you don't know what zero-shot prompting is, if you essentially zero-shot prompting is essentially when you just let the model generate responses to tasks it hasn't been trained on, right, at all. One-shot prompting or multi-shot prompting is a different approach to this, is where you let the model generate responses, but you provide it with, in the case of one-shot prompting, a single example of the task you wanted to perform, or several examples in the case of multi-shot prompting. And a lot of prompt engineering courses, especially the ones that deal with Claude, teach that one-shot or multi-shot prompting, especially for planning use cases, is really beneficial. But it turns out these researchers looked at this and was like, well, it tends to do more harm than good, especially when it comes to models such as Llama, which is very interesting. I just thought that would be an interesting point to mention. Right. Something else that is really interesting for product managers out there is this graph here, which contains the average amount of reasoning tokens and plan lengths for O1 preview, right? Which has real cost implications. So I'll talk a little bit about what reasoning tokens are here in a second, but to set the scene here, 1 million tokens on O1 currently costs, I believe it's $15. And O1 features a price per call, but it includes a surcharge based on the number of reasoning tokens that it uses, right? And these reasoning tokens are tokens that are generated as part of inference, right? And they don't tend to be revealed to the user. And they are charged at a significantly higher output token rate. The way you can imagine this is if you are going ahead and you ask the toddler in your life to think through a particular problem and explain their chain of thought to you, that person will then go ahead and ramble on in between actual thinking milestones until they finally arrive at the correct response. This is essentially the same that O1 does. It generates a bunch of tokens in that process during inference that inform the next step in its chain of thought thinking experiment, so to say. And what you can see here is if you ask an LLM or an LRM or O1 specifically in this case, to essentially develop a plan with 10 to 12 steps, it means that you're burning around 8,000 reasoning tokens per plan, right? That means that for $15, you can make up to 125, I think, plans. And in addition to the fact that currently end users have no control of the number of these tokens that are being generated, right? Depends a little bit on your prompt, depends a little bit on how O1 opens under the hood. It's a little bit opaque and quite deliberately being done so intentionally by OpenAI, right? These things can become costly very, very quickly, right? And so what essentially this research paper presents is it looks at the various models that you have here. So the blue is O1, the red one is O1 Mini, and then you have all the other ones, GPT-4 and Claude and so forth. You can see here they're sort of like scraping along at the bottom. And it asks them to complete a task by creating a plan for it and then executing on the plan. You can see here the success percentile here on the left and the number of steps in that plan here on the bottom. And you can see that the LLMs aren't actually doing that well. The more steps you introduce into the plan, right, the lower the success percentage is here. What is also interesting is that the paper actually offers an alternative, which we are going to call fast downward. Fast downward is a classical planning system based on heuristic search, which is not from last month, but was invented in, I think, 2006, and the paper was written in 2011. And this is, of course, not an AI model, right? It's essentially just a very powerful statistical model. But you see the power that we might introduce, by leveraging other kinds of logic, right? And maybe a classical logic by using heuristic algorithms that can present a shortcut that sort of makes the performance of our AI system way more tangible, right? You can see here that orange line, which is that heuristic planning system, does way better than all the LLMs currently out there. And essentially the way this works is if you've taken a computer science course, right, you've learned about different ways of searching or search algorithms, intelligent pathing algorithms. Essentially what fast forward does is it takes elements from local search, global best first search, multi-heuristic first search, and it combines them in a smart and very intentional way to create this really smart planning algorithm that can plan and solve rather complex planning tasks, right? And the reason why I include this here is because I think it's a really decent reminder that the principles of AI and machine learning have been around for a long time, right? And that not all AI needs to be LLM focused. Now, obviously, that has been the hockey stick in terms of adoption, but there are other mechanisms, smart algorithms that we can use to increase the power of the implementations that we're working on. So maybe, for an example, a better way to ask your LLM to use chain of thought reasoning to plan, right? A better way than doing that is to maybe go ahead and say, well, we're implementing a fast downward algorithm as part of this toolkit that creates the plan, and then the LLM goes about executing that plan. If you have a product that you're working on, right, where you want your LLM to create plans, that might be an interesting avenue for you to explore. Would definitely be more economical for sure, right? Cool. Now, this is the fast downward planning system, as I mentioned here, right? And you can check out that paper in that link below. Now, the last paradigm shift that I would like to introduce is related to an entirely different discussion and doesn't ultimately have anything to do directly with O1, but it also applies to other LLMs as well. That discussion that I'm going to talk about has been pretty prevalent in the LLM community, and is also played out in many professional conversations that I have. And that is, LLMs, especially the newer ones, right? They're becoming more and more powerful. And one of the indicators of that power is that they can ingest larger and larger amounts of context, right? And the question is, well, now that the context length for all of these LLMs is so low, do you even need RAG anymore, right? And for anyone unfamiliar with RAG, it stands for Retrieval Augmented Generation. And that essentially refers to this practice of combining LLMs with external knowledge databases to improve their outputs, allowing you to essentially use a pre-trained model like Llama, right, in a really custom setting by hooking up your corporate data to it, by hooking up your documents to it, right, or specific data, specific use cases, right? And RAG was or is of particular interest when LLMs had sort of like a shorter limit of how much context you kind of could include in actual queries. And so what people would do is they would store this additional information, usually in a vector database, and then use some kind of algorithms to use the most relevant information from that vector database and essentially give it to the LLMs and say, okay, do some reasoning based on the data that I've just given you, right? But what we're now seeing is, now that some of these LLMs have sort of like token lengths of like 1 million or 2 million tokens, which is like a ton of context, and people are essentially asking whether we still need that vector database to sort of inject information when we instead could just include the information in the query, right? And to explain this topic, we're going to look at two papers that are going to take a little bit of an opposing stand to each other. One is from DeepMind, arguably that is 2 months old, and one from NVIDIA, that's the one from September, that sort of resurfaced that whole conversation, right? And a quick TLDR, if you're worried about RAG and if you're a big fan of RAG, right, the conclusion will be is that we still need RAG, Retrieval Augmented Generation, but larger LLM context windows will definitely start eating away on some of those use cases that you used to need RAG for, if that makes sense. So the first paper, which is, as I said, a little bit older, and I've included the link down here, right, is called Can Long Context Language Models Subsume RAG, right, SQL and more, right? And in this paper, what they did is they took a lot. They took a lot of the long context language models that are out there, and they sort of explored the pros and cons of those long context language models. In this paper, they call them LCLM. I don't know what's about with everyone insisting on adding an additional letter to the LLM space, but so be it. That's what they were setting out to do, right? And the interesting thing about this paper is that they introduced this new benchmark set that sort of determines how good a long context language model is at doing these long context retrieval types of tasks, right? So what they did here is they applied 3 kind of tasks, right? So they essentially gave it the task to retrieve some information from sort of like a large body of information that covered text, that covered audio, and it covered also video, I believe. The second thing was they simulated a RAG environment where you retrieve something, but you then also process what you retrieved to sort of give an answer, right? Now, the purpose, again, of this paper gets a little meta, is to see how well you can replace RAG, but they still used the same terminology to describe what their experimental setup would be if you don't need RAG. It's a little bit confusing. I didn't write that paper. I would have called it something else, but just for everyone's context, that's what happened here, right? And the third is SQL, where essentially you directly query data instead of using SQL, right? Again, also in a simulated LCLM environment. And finally, also what they did here is they also tried many-shot ICL. ICL stands for in-context learning. And what you do here is you provide the LLM with a bunch of different examples, remember what I talked about earlier today, like single shot, many shot prompting, and you let the LLM essentially refine how it approaches the task based on the many different examples that you provided, right? And what they did is in this paper, they essentially went ahead and they compared, I believe it was 3 large language models. They took Gemini 1.5 Pro, GPT-4, and Claude 3 Opus. And they compared them with sort of a specialized model that was specifically fine-tuned and built to do these retrieval tasks. And I think their context space was like 10 million tokens. It was especially created for this particular purpose, right? And what they found is that overall, the long context language models performed really well. Oops, sorry. Oh, I'm going to go back here. They performed really well on these long context retrieval tasks, and actually a lot better than you would expect. But they did less well on those SQL use cases where they essentially went ahead and asked it to retrieve data, to expressively query and handle data that might be noisy or in a mixed structure of data, which is usually something that you would be hooking up different SQL databases in a RAG context, right? But what's also really interesting here is, and this is something that is useful for everyone who's watching this particular session, right? They looked at the fact that prompting in a context where you have a really large context window is a little bit different to prompting when the LLM already has all the context. So if you are working on any RAG pipeline, right, what they've discovered is that they've discovered this CIC prompting, which stands for Corpus in Context Prompting, which is a kind of prompting methodology that they've developed. And that prompting methodology exists because in large language models with really large context length, right, whether you give it to it by RAG or whether you give it through the context corpus that it has by itself, how you prompt that LLM really matters, right? And what they proposed is this particular format that worked really well for them, right? And essentially what this contains is you essentially provide instructions of what the LLM should do as step 1. In step 2, you sort of embed the corpus, right? And what they highlighted is that the formatting of that corpus is really important. You see here there's an ID, there's a title, like there's an end ID, those kinds of things. That is really, really important here. And you can read about that in how that works in detail in the paper. You've got the link down here, right? And then they provide a few short examples, right? So you can see there's an example here. And lastly, you prompt it using chain of thought, right? Which is basically telling the LLM to explain how it's trying to solve this problem. And finally, right, you go ahead and ask it the question that you wanted it to ask. So if you have a RAG use case or a LLM use case with a really large corpus, maybe worthwhile considering, because this seems to have worked very, very well for DeepMind, right? Now, something that they also discussed in this paper, however, is that DeepMind acknowledges that this kind of context and corpus prompting does have a few drawbacks, right? On the one hand, it's not super efficient. And on the other hand, while it's really accurate, it can be really, really expensive and cost prohibitive. And this is now where NVIDIA comes in, right? And NVIDIA went ahead and looked at this paper, and a couple of months later, so now in September, right, they published this, which is called In Defense of RAG in the Era of Long Context Language Models. And essentially what they said is, yes, LLMs are often better than RAG these days, but they're not super efficient. So what they introduced is a different way of doing RAG called order-preserved RAG, where rather than pulling the most relevant pieces of context and throwing it at the LLM, you keep the order this context was originally in from the original body of text, and so take bits and pieces out, right? But by doing that, they were able to outperform the LLMs by using this method with a lot fewer tokens used, right? And what they also found was that with RAG, which is interesting here, right? Providing more context initially increased the accuracy, right? As you can see here, right? But then sort of kind of dropped off over time, which you would also expect for large language context, for long context language models, but the drop-off is significantly less than RAG. So there is too much of a good thing when it comes to context in retrieval augmented generation pipelines, and that doesn't seem to apply as much to long context language models, right? Now, why did I include this in the discussion? Well, I included it because we have these kinds of conversations with the people that I'm working with and at my company specifically as well, right? Whether we should be using intelligence of the LLM itself to find a needle in the haystack, or whether we should be using a specific tool such as vector databases that were specifically designed for this particular job, right? And this is an interesting paradigm shift that we're now sort of slowly starting to see in, and it's really going to take hold when those long context language models become less cost prohibitive, because they're going to start eating away at those RAG use cases bit by bit, which then leads to, you know, us in the product world or in the technology world having to change our architectures or making them a lot simpler, which could be nice as well, but we're not there yet. Cool. Other than this, before we get to questions, there were also a few other papers that we didn't get to. I think in the very first episode, we briefly talked about Kolmogorov-Arnold transformers, which is essentially a different way, an alternative to building AI without, you know, the incremental node as part of a neural network. Really fascinating, right? A lot of people in the AI space are actually saying that CANs or cats in this case are going to be the future of AI. And this is the first time a paper was published where the Kolmogorov-Arnold transformer performed better than transformers currently built on the standard neural network principles, which is really interesting, right? And then the other thing is a little bit of fun here. If you haven't checked out Moshi, you can Google Moshi. It's a really cool, very, very naturally sounding speech to a voice foundational model for real-time dialogue. You can go you can go Google it. You can go to the website and you get 5 minutes with Moshi. Very, very impressive. And this paper is also a really good read. So that was it from me for today. Would love to hear any questions you might have. I hope I didn't bore you to death. It was interesting and engaging. If you have, however, any suggestions as to what we should have covered or something that we should be covering in the future, I would love to hear that. And as always, you can always reach out to me to hang out in the chat or something. Cool. Excellent.
Does anyone have any questions?
No? Ramin?
Yeah, just a comment on RAG. It's a really interesting topic. I've had to deal with RAG a lot at LucidLane and other projects, and I really believe that the topic or the use cases that have to be really grounded to the truth have to have RAG. You can't just leave it up to the model to figure out and come up with the right answer. If you really have to have the right answer, output it. For example, in the healthcare environment, you really have to make sure that what you're saying is true and valid. And the only way to do that is just to validate that the output of the LLM is correct by looking it up and validating it against some source of truth.
Yeah, I think that is such a great observation, and completely aligns also personally with my experience, right? I think another way to describe this is, it seems like large language models now and potentially moving into the future, they sort of suffer from this diminished focus on relevant information with more and more context that you're introducing, right? And that leads to potential degradation in answer quality. My personal opinion is, right, when the LLM is asked to find some relevant context, they can do that needle in a haystack search, but they might not be doing it really well, right? Vector databases were specifically created for this needle in the haystack problem, right? And they're therefore better at finding it. They're better to control. In your RAG pipeline, you have way more insight into what's going on. So especially when precision, repetition is important, I'm fully there with you. I think RAG will be around for a very, very long time. Yeah. Totally agree.
Great presentation.
Oh, too kind. Too kind. Excellent.
Really good, Mike. What do you think are the next steps to actually improve RAG? Because there's still obviously things that need to be done to, and as Raman said, you know, when it comes to health records or, you know, education thing or financial things, they need, you know, the answers need to be spot on, and there's still human in the loop half the time. You know, what are the next steps to improve that, do you think?
Yeah, I think this is so interesting. I think there are, so one of the biggest impediments, just from a business perspective, let's talk about business perspective, not so much technology, but let's talk about business perspective for a second. One of the biggest impediments that enterprises are currently citing, as of last month actually, with the large scale of implementation of AI and AI solutions in their business, is the incredibly high competition for talent in that space, and for expertise in that space. And doing RAG right requires a significant understanding of how large language models work, right? Yes, you can do, you know, a Udemy course and you get the basics down, that's fine, but applying or designing a RAG pipeline to work at scale, right? Building an architecture that can provide repeatable results that are really consistent, that is a challenge that requires significant expertise, in my opinion. And anyone who's working on this from an engineering perspective is worth every single penny they are charging, and probably more. But I think one of the things that might be happening is that people are going to do more research and investigation around how building LLM pipelines and RAG pipelines can be made easy. As a matter of fact, I have a little example here. I'm not sure whether you can see that because I might not be sharing my screen. Oh yeah, here we go. So this is a paper that I was thinking about presenting, but then it didn't make the cut. But this is also really, really interesting. It's ChainBuddy. It's an agent system for generating LLM pipelines, right? And what is really interesting about this is that we are still lacking in the a cohesive tool set to allow us to very easily spin up these various pipelines. Yes, if you know VS Code, you essentially covered and you can pull things together, right? But there is no I think widespread, generally adopted framework that serves as a universally understood standard, the way React is you know, in the JavaScript world, for example. And I think we're going to see more standardization around this. I think the communities are going to congregate around particular frameworks that are already out there, that are seeing significant adoption, that are going to have the right amount of support and open source muscle, right, to make that, to have some standards emerge there and make that easier, if that makes sense. That's my projection. We'll see whether I'm right or not.
Just to add to that, I really believe that the one of the other impediments for RAG is the cost of doing of implementing the RAG systems, where you have, if you think about, the typical architecture for RAG, you have preprocessors, you send it to the LLM, you do the post-processing, and you validate it against the source of truth source. And all of that has to be sequential, and it takes a lot of time, it takes a lot of money to actually implement that. And it's not necessarily applicable for every use case, or not every use case can wait for that much time to be processed throughout all the different layers of RAG. And I think, at some point, when you introduce some kind of parallelism into the architecture, or reducing the cost of the actual LLM, running the LLM multiple times, that would help speed up RAG implementations quite a bit, but I don't think we're there yet.
No, you're absolutely right. Raman, do you work on those particular? You said you're working quite a bit with RAG and those challenges that we're all encountering. They sound like lift challenges. Is that the case for you?
Yeah, we had a lot of challenges in terms of just implementing RAG for specifically to make sure that the output of the LLM is valid against a database or source of truth that we had in the we had a healthcare system product and service, so it was very important for us to make sure that the data was valid coming out of the LLM, and it wasn't just hallucinating or just catching nonsense stuff coming out of it. So
yeah, that sounds like particularly in these compliance sensitive sectors, that sounds like a significant challenge, which everything that you said about makes total sense, because you can't just go with the first response that you're receiving. Right. I can imagine, right, that you're receiving back from the LLM, right? It needs to be vetted, and then it needs to be regenerated, and then sometimes the LLM goes down a rabbit hole, and you need to pull it out. Like, this is very, very interesting. Yeah, very interesting. I'd love to learn more about what you're doing. It sounds like a really, really exciting challenge, and how you're solving those challenges is a thing that a lot of companies are worrying about, right? I have a friend who works in the gambling industry, and even those guys, with all the resources that they have, repeatable outputs, incredibly beneficial in that particular sector, but very, very hard to do. Very hard to do.
Mm-hmm. Absolutely.
Great stuff, Mike. Anyone else want to ask a question? We've got a few minutes left.
Oh, it was all Raman, actually. Like, great questions, great comments. Really appreciate it.
Well, if not, look, we'll wrap it up. We're pretty much at an hour. So again, Mike, massively appreciate you taking the time. Very, very interesting. A lot I've got to process over the next few hours just to get my head around all the changes. But I thank everyone else for getting involved. I obviously really appreciate it, and I hope you got a lot out of it.
Wonderful. Thanks so much, everyone. And if anyone would like to connect with me after this, I'm Nedelko on LinkedIn. Would love to chat with you, or maybe even meet up for a coffee if we're sharing geographic locations. And thank you again, Dylan, for putting on this wonderful community. It's always an absolute pleasure, and it's the highlight of my month. So I'm looking forward to the next one.
Good stuff, Mike. Thank you very much, mate. And see you all soon.
Thank you, Dylan. Thank you, Mike.
Thank you. Take care.
Guys.
Bye.
Bye.